In this video, we will discuss about second problem based on matrix chain multiplication. Input is dimension vector D is equal to 15, 5, 10, 20, 25. D0 for 15, D1 for 5, D2 for 10, D3 for 20, D4 for 25. From the dimension vectors, we can find out the size of matrices and how many matrices will be there. Now here the first matrix is A1. A1 is equal to 15 by 5. This is the size of first matrix. Size of A2 will be 5 by 10. 5 by 10. Size of A3 will be 10 by 20. Size of A4 will be 20 by 25. So in this way we have got 4 matrices, that is n is equal to 4. Now once we have got the value of n, we have to specify the structures of two tables, M table and the S table. Now in the M table, J starts from 1 to n. N is nothing but the number of matrices, that is 4, and I starts from 1 to n, that is 4. Now once we have got the structure of M table, so draw the structure of S tables. Now in the S table, J starts from 2 to n and I starts from 1 to n minus 1, that is 3. So in S tables, we are not consider the bigger diagonals from the M table. Just we have removed the bigger diagonals to get the S table. So there are 4 diagonals. Start from S is equal to 0. For S is equal to 0, so there are 4 cells. For S is equal to 1, there are 3 cells. S is equal to 2, there are 2 cells. S is equal to 3, there are 1 cell. Now we have to start from S is equal to 0. For S is equal to 0, use first formula. For S is equal to 1, use second formula. For S is equal to 2 and onwards, use third formula. For S is equal to 0, we have for I is equal to 1 to n minus S. So n is 4, S is 0, that is 4. Means 1 to 4. For S is equal to 0, there are 4 cells. We have to find out the values for these cells. Now start from I is equal to 1. For I is equal to 1, use the formula m of I comma I is equal to 0. Means m of 1 comma 1 is equal to 0. Put here at 1 cell, that is 0. Then I is equal to 2. M of 2 comma 2 is equal to 0. I is equal to 3. Means m of 3 comma 3 is nothing but 0. Then I is equal to 4. M of 4 comma 4 is equal to 0. Now in this way we have got the values for S is equal to 0 and put these zeros in bigger diagonal 0, 0, 0, 0. Now then for S is equal to 1, for I varies from 1 to n minus S. So value of n is 4 and value of S is 1, that is equal to 3. It means that, so we will get 3 values starting from 1 to 3. Means for S is equal to 1, there are 3 cells, 1, 2, 3. For I is equal to 1, use second formula. M of 1 comma 2 is equal to di minus 1, means d0 into di, that is d1, into di plus 1, means 1 plus 1, d2 is equal to, so we will get the values of d's from dimension vectors. D0 is 15, so D1 is 5, D2 is 10, is equal to 750. Then I is equal to 2. M of 2 comma I plus 1 means 2 plus 1 means 3 is equal to di minus 1, that is d1, di, that is d2, then d3. So put the values. So d1 is 5, d2 is 10 and d3 is 20 is equal to 1000. Then take next value of I is equal to 3. M of 3 comma 3 plus 1 means 4 is equal to di minus 1 means d2, di, d3, di plus 1 means d4. Put the values. So we get d2 is 10, d3 is 20 and d4 is 25 is equal to 5000. Now put these values in M table at 1 2 position. At 1 2 you will get 750. At 2 3 you will get 1000. 2 3 value is 1000. At 3 4 value is 5000. In this way we have got the values for S is equal to 1. This is for S is equal to 1. Now go for S is equal to 2. For S is equal to 2, we have for loop for I varies from 1 to n minus S. Value of n is 4. Value of S is 2 is equal to 2. That is 2. And for S is equal to 2, there are 2 cells. Now for I is equal to 1 and for S is equal to 2 and greater than 2, we have to use third formula. But before going to S is equal to 2, so we have to see S is equal to 1. Now for S is equal to 1, we have got 750 and this value we have got for I is equal to 1. Means from this we have to start to fill up the S tables and we have got 750 for I is equal to 1. That's why we have to put here the 1. Now here we have got 1000 for I is equal to 2. That's why we have to put here 2. We have got 5000 in M table for I is equal to 3. So that's why at 3 4 position in S tables we have to put 3. Means directly you can put 1 2 3. Now then let us go for the S is equal to 2. For S is equal to 2, for loop varies from 1 to n minus S, that is 4 minus 2 means 1 to 2. First we take I is equal to 1 and we have to use third formula. So M of I value is 1 and I plus S, I is 1, 1 plus 2 that is 3. Means cell will be 1 3, this cell is equal to mean. So write down the condition I is 1 less than equal to K less than I plus S. So I is 1, 1 plus 2 that is 3. K varies from 1 to 2. Means you will get two values, one for K is equal to 1 and another for K is equal to 2. First start from k is equal to 1. So m I comma k, m 1 comma 1 plus m of k plus 1, that is 1 plus 1, 2, I plus s is given, that is 3, plus di minus 1 means d1 minus 1, that is 0, dk, that is 1, d1, then di plus s means d I plus s is 3. Put the values. m11 is 0 plus m23 is 1000 plus d0, value of d0 is 15, value of d1 is 5, value of d3 is 20, is equal to 2500. Then take next value of k, that is k is equal to 2. Use the same formula. M of ik, I is 1, k is 2, plus m of k plus 1, that is 2 plus 1 is 3, comma I plus s is 3, plus di minus 1 means d0, dk means d2, then di plus s means d1 plus 2, that is d3. Put the values. M of 12 is 750 plus m of 33 is nothing but 0 plus d0 is 15, then d2 is 10, then d3 is 20, is equal to 3750. So out of these two values, minimum value is 2500. Select the minimum value for the cell m of 13. So at cell 13 you will get the minimum value 2500. Right here 2500, and we have got the minimum value for k is equal to 1. So this is for k is equal to 1 and this is for k is equal to 2. So we have got this minimum value for k is equal to the 1. Now in S table at 13 place, in S table at 13 place put k is equal to 1. Then take next value of I is equal to 2. For I is equal to 2, m of 2 comma I plus s, value of I is 2, 2 plus 2, that is 4, means 2 4 cell, this is the 2 4 cell. So mean, so I is 2 is less than equal to k less than I plus s, that is 4, I plus s is 4. Then k varies from 2 to 3. First take k is equal to 2 and apply this formula. M of ik, m of 2 comma 2 plus m of k plus 1 means 2 plus 1, that is 3, and I plus s is nothing but 4, plus di minus 1, that is d2 minus 1 means d1, d2, then di plus s means d4, is equal to, put the values, m22, so m22 is 0, plus m34 is 5000, plus d1, we have d1 5, we have d2 10, we have D425. It comes to 6250 for k is equal to 2. Similar way, find out the values for k is equal to 3. M of ik, I is 2, k is 3 plus m of k plus 1, so k is 3, 3 plus 1 4, comma I plus s is nothing but 4 plus di minus 1 means d2 minus 1 d1 into dk means d3 into di plus s means d4. Put the values. M23 is 1000 plus m of 44 is 0 plus t1, value of d1 is 5, value of d3 is 20, value of d4 is 25. It comes to 3500 for k is equal to 3. And out of these two values, minimum is 3500. So write 3500, add 2 4. 2 to 4 value will be 3500, and we have got this value at k is equal to 3. At k is equal to 3 means in S tables put k is equal to 3 at 2 4 positions. At 2 4 positions put k is equal to 3. In this way we have completed S is equal to 2. Now then go for S is equal to 3. For S is equal to 3, for loop start from 1 to n minus s. Here n is 4 and s is 3 is equal to 1, means 1 to 1. I varies from 1 to 1. So there is single cell, and for this cell we have to find out the minimum value. For this use third formula. For I is equal to 1, m of I comma means I is 1, I plus s, so 1 plus 3 that is 4. So 1 comma 4, 1 comma 4 means this place. Mean value of I is 1, 1 less than equal to k less than 4. So case varies from 1 to 3, means there will be 3 equation for k is equal to 1, k is equal to 2, k is equal to 3. First we take k is equal to 1, m of I comma k means 1 comma 1 plus m of k plus 1 means 1 plus 1 2 comma I plus s is 4 plus di minus 1 is nothing but 0 dk d1 di plus s, that is I plus s is nothing but 4, is equal to m11 that is 0 plus m24 224 3500 plus d0, so value of d0 is 15, 5, 25, it comes to 5375 for k is equal to 1. Take next value of k, that is k is equal to 2. m of I, value of I is 1, 1 comma 2, plus m of k plus 1, so k is 2, 2 plus 1 3, comma I plus s is 4, plus di minus 1, that is 0, dk means d2, and di plus s means d4. Put the values. M of 1 2 is 750 plus m3 4, 3 to 4, that is 5000, plus d0 is 15, d2 is 10, and d4 is 25. It comes to 9500 for k is equal to 2. Then take next value of k, that is k is equal to 3. Use the same formula. M of I, value of I is 1, k is 3, plus m of k plus 1, that is 3 plus 1 means 4. I plus s is nothing but 4, means this value, plus, so di minus 1 means 1 minus 1 means d0, dk means d3, then di plus s means d4. Put the values. M13, so 1 2 3 2500, plus m of 4 comma 4 means 0, the d0, value of d0 is 15, value of d3 is 20, value of d4 is 25. It comes to 10,000. This is for k is equal to 3. So in this way we have got three values: 5375 for k is equal to 1, 9500 for k is equal to 2, then 10,000 for k is equal to 3. Out of this, minimum is 5375. 5375. Put these values at 14. At 14 position, it is 5375, and we have got 5375 for k is equal to 1. Means put k is equal to 1 in S table at 14 position. In S table at 14 position, that is 1. So in this way we have developed M tables and S table. Taking the reference of the S tables, we have to draw the tree structures to get the optimal parenthesization. Now start from 1 4 position, means 1n position. S of 1n means 1 4. Show two children, left child and the right child. S of 1 comma dash, then here S of dash comma 4. 1 will be here, 4 will be the right side. Then what is the value at dash position? So find out which value is there at cell 1 4 in S table. 1 4 value is 1, so you will get 1 here, and add 1 to this 1, so you will get 2, and put this 2 at this place. So in this way we have got the 2 comma 4, and before this left child show the opening bracket, after right child put closing bracket. Now check out whether this side can be grow or not. We have to check whether 1 comma 1 cell is there. So 1 comma 1 cell is not there, that's why we have to stop growing the tree this side and put here the A comma J, J is 1. Now then this side S24, 224 cell is there, that's why we can grow this side. Show the left and the right child with opening bracket and the closing bracket. Here S 2 comma dash, this side s dash comma 4, then put the value at dash position. So for that we have to find out the value at this cell in S table. 2 to 4 value is 3, so write here 3 and add 1 to this 3 to get the value for this position. So 3 plus 1 means the 4. Now here, so you can grow this side, you can grow the tree this side, because 2 3 cell is there, 2 3 cell is there. So enclose left and the right child using opening and closing bracket. Here write s of 2 comma dash, 2 comma dash. Here write s of dash comma 3. So what will be the value at this position? For that we have to find out the value in S tables at this position 2 3. So 2 3 value is 2. So write here 2. Then add 1 to this 2 to get the value at this position, that is 3. 2 plus 1, it is 3. Now check out this cell is existing in S table or not. This cell is not existing in S tables, that's why write here A of j, j is 2. Here 3 3, again 3 3 cell is not in S table, write A j, that is 3. Now then this right child is left. Now check out cell 4 4 in S table. So there is no cell in S table, so that's why write here AJ, that is 4. So in this way we have developed the tree, and from this tree we have to show the optimal parenthesization. Optimal parenthesization is, now start from down to up, means leaf node to the root of the tree. Now here the opening bracket is there. Inside the opening bracket, so there are two matrices A2, A3. A2 is multiplied with A3. Okay. Now same will come as the at this place. So before this there is an opening like this. Then so after this, so there is A4, means into A4, and after A4 there is closing bracket. So then consider the same thing at this place, means after this place, so there is closing bracket, and before that there is A1, means before that there is A1, and before A1 there is opening bracket, this one. So in this way, so we have obtained optimal parenthesization, which gives us the minimum number of multiplication operations, that is 5375, 5375.